Alright, electric motor division 645 engine, section 2, cylinder head and accessories. Alright. Alright, you got your cylinder head assembly, description, maintenance, valve and spring removal, valve guides, cleaning, cylinder head leak test, inspection, cylinder head rebuild, injector hole rework, fire face, refinish, valve seat grinding, exhaust valve description, maintenance, cleaning, inspection, grinding valves, valve spring seat lock, exhaust valve seat installation, valve stem height check, valve seat seal test, exhaust valve bridge assembly description, cleaning, disassembly inspection, last adjusters, disassembly cleaning, inspection assembly, qualifying last adjuster, valve bridge assembly, rocker arm assembly, description maintenance, rocker arm support assembly, description maintenance, cylinder test valve, description maintenance, cylinder head seating ring, description maintenance, service data, specification, equipment list. Alright, cylinder head and accessories, engine maintenance manual, section 2. Cylinder head and accessories, cylinder head, description. Cylinder head in figure 2-1 is made of cast iron alloy with cast passage water and exhaust gases. Drilled water holes, bottom cylinder head match the water discharge holes in the liner. Cooling water is circulated through the head and is discharged through the elbow, mounted on the side. Head mounting flange, exhaust passage in the cylinder head line up, and elbows in the crankcase with the conduct the exhaust gases. The water discharge manifold to exhaust manifold, as well located in the center of the cylinder head. Application unit fuel injectors to ensure correct position of the injector. A mating hole for the injector locating dowel is located in the head. Figure 2-2 shows the rocker arm, exhaust valve, valve bridge, spring, valve guides of overtrip pawl, fuel injection, other related items, making the complete cylinder head assembly. Alright, note, procedures, disassembly and qualification cylinder head components contained in this section. Procedures, removal, the installation of a cylinder head, complete cylinder power assembly is contained in section 5. So this would look like your cylinder head valve assembly with valves. Alright, you have your rocker arms, your overpaw seat, overspeed paw, the cam support cap screws, rocker arm shaft support, injector crab, valve bridge, valve seating, injector valve spring and locks, cylinder head, exhaust valves. Figure 2-2 shows the cylinder head in exploded view. 2-3 shows the compression tool, valve springs, the compression of the valve springs. Alright, your exhaust valve and spring removal. Remove the exhaust valve spring, single valve, single compressor adapter screwed into the head, multiple valve spring compressor. Figure 2-3. Compressor spring sufficient to remove the valve spring seats and then remove the springs. After spring removal, the exhaust valve is removed from the bottom of the head. Note the valve springs remove them in place without removing the cylinder head from the engine. If this is done, the piston must also top the center to prevent the valves from falling into the cylinder while the valve blocks are removed. Alright, your valve guides. Cast iron guides are press fit cylinder head can be pressed into or out of with the damage of a valve guide installing a removal tool. Although the valve guides generally do not require reaming after assembly, it's recommended the plug gauge inserted aft alter guide installation into ensure minimum diameter. Alright, your clean cylinder head. Clean the cylinder head in suitable solvent. Remove the strip of the oil solution baked on carbon. Cleaning should be in accordance with accepted practice or as recommended by the supplier of the cleaning material. Caution, do not use any form of blast cleaning, glass, sand, or shot on the fireplace of the head as the blast tends to remove the sharp edge of the phonographic grooves of the gasket surface, reducing sealing effectiveness. 2. Remove the loosened materials from the stud holes using the hole cleaner, 115 volt, 200 or 230 volt drill. Figure 2-4. Figure 2-4 shows cleaning stud holes. Alright, the cylinder test valve used threads using standard 1.5 inch pipe thread. Use valve guide cleaning 115 230 volt drill. Clean guide is shown in figure 2.5. Any evidence of the galling inside of the guide must be entirely removed by reaming. The guide should be replaced, and the inside diameter of the guide should not exceed the limit measured at the bottom, a half inch in the top and bottom. Alright, figure 2-5 shows your cleaning valve guides. Clean phonographic finish fire face using wire brush circular motion to remove the dirt and carbon phonographic grooves. Your cylinder head leak test. See all water passages in the head. Assemble the 586 to 655 kilopressure pascals of air pressure or 85 to 95 psi air pressure passage. Immerse the head in water and maintained at 160 degrees Fahrenheit 2 to 2 minutes using method. Leaks easily detected. Minor leaks open head up and by hot water easy detection. Note, when performing a cylinder head leak test, scrap injectors should be installed using an injector crab. Cylindrical washers and nuts, torque nuts at 60 to 10 pounds, plus or minus 10 pounds. Foot-pounds immersion into the hot water. Core plug leaks usually prepared, replacing plugs. The leak caused by cracks, porosity, dirt inclusions are cause for rejection. Alright, your inspection. Inspect the cylinder for cracks using Magnaflux procedure. A small Magnaflux indication of the bend between the injector hole with the fire face between the removed machining of the grinding scratch neck sealing area with the head with the gasket grommet sealing areas next to require fire face refinishing. Small scratches, nicks, and phonograph finishes are outside of the sealing areas of the head gasket or the grommets do not require refinishing. Small scratch and nicks are permissible in the area of the inboard combustion gasket sealing area on the fire face of the head. If so much small defects exist, there is no need for the refinish of the face. Inspect valve seats, burn areas, perform dimensional checks. Seats are not meeting visual or dimensional criteria must be resurfaced. No, any head removed from the engine that has been overheated with a cookout with the heads of linear grommet should be scrapped due to the irreparable damage to the head. Cylinder head and rebuild. The cylinder head and the damaged valve seat with the flange seating surface of the fire face surfacing injector hole should be reworked in accordance with the following procedure. Injector hole rework. Blend chatter marks and ground gouge smooth at the injector hole fire face surface. Leave no sharp corners injector seat side and fire face side with the blend. Do not extend maximum injector hole with the maximum allowable blend radius figure 2-6. Alright, your fire face and your flange seating surface refinish. Refinishing the cylinder head, fire face, and flange requires small special tool processes. Alright, this shows your figure 2-6 shows the injector hole rework. Maximum 3/16 of an inch and minimum 1 inch. Rework blend. Following paragraphs contain recommendations. Following tools and procedures meet the requirements. Figure 2-7 shows the rework mounting face is flat parallel to the fire face using 0.2 of an inch. The vertical lathe recommended with the ease of loading and unloading, although the machine is capable of chucking and turning the head will do. The following commercial tools are listed for references. Insert Valnite SPC 424/8 grade VC 28 1/16 nose radius. Insert hole Valnite NVSDN 12C. By the way, happy Valentine's Day. It's February 12th. Depth of the cut should be held with a minimum extended reconditioned life of the head. A cut of 6,000 to 8,000 for the inch on the gasket surface and 10,000 to 16,000 on the mill surface should be sufficient to clean up these fire face. To minimize the depth of the cut, the care should be taken to set up the fire face rather than locating off the top of the flange. The set of 24,000 inches per revolution RPM varied but maintained at 250 SFPs. To achieve the constant speed of the spindle speed will have to be increased as the tie tool approaches the center of the towel head to avoid tearing the surface of the head around the towel injector hole. Or the distance between the underside of the flange and the gasket surface of the fire face must be maintained. Figure 2-7 hold the dimension. With a specification, it will generally be necessary to machine the fire face underside of the flange simultaneously because of the tight requirement parallelism with the tie underside of the flange fire face. Figure 2-8. However, the cut of the underside of the flange should be held with a minimum within the allowable range of fire face to the flange dimension. The sharp edge of the chamfered blend injector hole fire face must be blended with it smooth using emery cloth. Deep scratches, gouges should be reworked into accordance with the injector hole rework. Valve seating grinding. To ensure a uniform seat with the proper location setting area relatively to the seat with exhaust while holding specifically concentric valve guide bore, the valve seat inside and diameter, outside diameter, and seating surface must be ground relatively center line of the valve guide bore. Using any of the valve seat reconditioning tool sets listed in the data, perform the following procedures. Mount each of the 3 grinding wheels on its own holder, address 45 degrees wheel 65 degrees to the 30 degree wheel to 20 degrees and the 30 finishing wheel to 30 degrees. Using a separate dressing tool for each wheel, maintain the seat angle and accuracy. Alright, this shows your reworked, your fireface angle refinish, original, and reworked finish. Lubricating dressing tool at pilot light film on the oil. B, mounted grind wheel holder dressing tool pilot figure 210. Check the dressing tool and adjusting the proper angle of the tool to be dressed. Alright, this figure 2.9 shows your valve seat grinding wheels and holders. Inside diameter 65, outside diameter 20, seat surface 30. Alright, figure 210 shows your dressing valve seat wheel grinder, grinding wheel holder, grinding wheel dressing valve tool. Alright, apply the driver wheel holder, rotate the wheel holder with a high speed, holding the driver as straight as possible. Move the diamond steady across the wheel, taking light cuts of the wheel face as smooth and at a proper angle. Select tapered pilot, which will bring the shoulder of the pilot above the valve guide. Press the pilot formally into the guide using pin figure 211. Wipe the pilot with any oil cloth that has fixture 212 available. Checking tapered pilots is to assure satisfactory result. Pilot run out should not exceed 5/10,000ths of an inch. Install lifter spring over tapered pilot. Figure 213, place 30 degree grind wheel hold over the pilot and spring. Apply driver wheel holder, grind 30 degree angle seat angle with the width of the seat at least 93,000ths of an inch. All the way around, driving the motor should be held with as straight as possible. Figure 214, operate with a top speed wheel grind wheel raised grind motor as off seat may become stopping the motor. Alright, move 30 degree grind wheel and apply a 65 degree grind angle and hold over the pilot, lifting the spring. Alright, figure 211 shows your tapered pilot installation. 212, tapered pilot fixture check. 213, your lifting spring application. 214, grinding valve and seat. Alright, 6, grinding 65 degrees until the area of adjacent with a 30 degree seat is smooth and clean. Note, grind away a little material possible, mimic the wear life of the seats. Move 65 degree grinding wheel, apply 20 degree grinding wheel, hold over the pilot and lifting. Grind 20 degree angle until the adjacent with a 30 degree seat, clean and smooth. Continue grinding until the seat width of the specified tolerance. Check the valve seat with the proper dimension, figure 215. If seat outside diameter is too small, we're grinding the seat of 30 degree until outside diameter is proper dimension. The grinding seat with the inside diameter of the 65 degree is until the proper seat width is obtained. If the outside diameter is too large, regrind the outside diameter with a 20 degree grinder until the outside dimension is obtained. If the seat is too small, grind the seat with a 30 degree grinder to outside diameter with a 20 degree grinder alternately until the proper outside diameter seat width are obtained. Alright, this shows your 215 shows your valve measurement points. Your outside diameter valve seat width, surface valve grinding bore, rim thickness, valve flat head, valve face width, valve seam diameter. Reapply 30 degree wheel and grind slightly to remove burrs and improve surface finish. Use a dial indicator of the valve seat reconditions measurement trueness of the valve seat. Place indicator over the pilot, figure 216. Adjust the indicator is depressed and slightly. And the ball valve seat rider in the center valve of the seat. Rotate the valve seat rider. Observe the indicator reading. Valve of the seat or out and around will indicate on the dial. Indicator reading must not exceed limit. 12. With the head position at the fire face up, install the new valve. Each position measure the vertical distance of the fire face of the head, rim, exhaust valve, figure 215. Archer exhaust valve. The long steam exhaust valve with the fabricated forged nickel chromium alloy head, steel tippet, hardened steel steel stem means of friction welding, bending valves, holding valve, and tapered spring seat precision valve guides ensure proper valve seating. Shows the stem radius, face, the rim outside diameter, cup, and flat. Alright, your maintenance. Handle valves carefully avoid nicks and scuff that might make the valve unfit for use. Pilling the valves on the top of each other that may cause the nicks of the outside diameter and the throat radius, which can lead to valve failure. Before the valves can be reused, they must be reconditioned with the dimension listed in the surface data at the end of this section. Cleaning. Thoroughly clean the exhaust valve. Use a suitable solvent to remove the surface oil, loose carbon, and if necessary, glass bead. Vapor blasting. Remove the hardened carbon deposit from the valve. The grit vapor blast must be maintained at a small enough size so the surface finish of the valve stem is not roughened beyond 0.635 U's an inch or 25 U's an inch. If the glass bead blasting is not available, the wire brush may be used as an alternative. Hard inspection. Exhaust valves must be qualified by the visual Zygolo inspector prior to reconditioning. Simple condition with which allow for the reuse. Rejectable condition of the scraping of the valve are listed below. The valve surfaces are referenced are identified in Figure 217. Acceptable conditions. For lifting, pilot valve face can be cleaned with up to the maximum allowable valve face limit. The protruding nicks and gouged valve stem must be removed before the valve face is ground in order to avoid scuffing the valve guide. Ensure proper valve facing running out. By sanding buffing may be used for pushing off protrusions, provided with the surface finishing with the stem maintained below 25 units, 25 U. I forget what that per symbol is, an inch, with a circumferential lay. Rejectable conditions indication for the cup area at Figure 218 defects of the rejection of the valve. Any cracks found in the outside rim of the ring section of the valve, Figure 219, cause for rejection since rim cracks usually extend some of the distance of the valve face. They usually lead to failure. Shows Figure 218 shows cup defects. And 219 shows face and ring defects. Face area, Figure 219, the critical area of the valve, grind cracks, channel thermal cracks, or cause valve rejection. Fitting wear of lock of the groove area of the stem is cause for rejection. Rejection valves have been damaged, critical surfaces that have been nicked or scuffed. Your grinding valves. Okay, following instructions supplied with 115 230 volt grinding or grinding valves completely listed for the equipment required for the machines contained in the steel service tool catalog. Or your valve spring seat and lock. Inspect the valve spring of the valve bridge with the spring with the angle of the next unusual wear. Valve spring should be clean with a suitable solvent with a soft wire brush. Do not hydroblast or grit blast. Valve spring should not be protected and prevent rusting. Before dimensioning pressure checks to qualify with the valve spring sheet should be clean and smooth, but the thickness of the spring seating surface should not be less than 2 minimum limit. Examine the valve leaks for the signs of excessive wear of the upper portion of the bead for evidence of excessive fretting in the ground diameter. Engage the valve stem. If the condition exists, lock should be replaced. Figure 220 shows your valve spring seat lock. Alright, your exhaust valve installation. After exhaust valves have been reconditioned, they are applied with a reconditioned cylinder head. They position a head problem, complete the assembly, valve spring a seat, and valve lock. Your valve stem height check. Check the bottom of the tram feet portion of the head of the feet rest. Apply tram firmly on the cylinder head. It shows a feeler gauge valve checking tram. Figure 221. Alright, use the feeler grid and the tram adjusting screw to determine the difference of the valve stem height. The difference between the valve stem under the same bridge, no more than 1/16 of an inch. The difference varies between 1/16 of an inch of high value should be replaced with a low valve grounding in, provided that this does not exceed the limit. The valve stem should not be grounded off the tip of this harden. Alright, your valve seat seal test. Place the head with an angular position resting on the rack arm stub. Valve seats in the up position. Wipe bottom of the head to remove the dirt of the dust. Apply light film oil with a concave surface. Tester vacuum cup. Attach the tester to the cylinder head. Handle in 6 o'clock position. Covering one valve. Alright, figure 220 shows use the testing valve seat valve. Ensure the tester cup is firmly seated on the fireplace, not in the head of the valve. If the tester suction is fireplace depleted less than 2 minutes, the valve seat is defective. The head seat and the valve face must be reworked. Open the trigger valve to remove the test from the head surface. Check the valve seat for the lesser. Apply it into the vertical piece of glass. As the release of the valve of the rubber cup may be defective. Exhaust valve bridge assembly. Our description: the valve bridge in figure 223 operates as 2 exhaust valves from one rocker arm. If the spring seat are held with the valve bridge stem by locking, spring seat rests in the socket of the cylinder head and the spring applied with the pressure to maintain the contact between the valve bridge and the rocker arm. The hydraulic lash adjuster means a zero lash between the end of the valve stem and the valve bridge. Lube oil flows to the rocker arm from the drill message valve bridge and onto the top of the lash adjuster. Push past the ball check into the body when the rocker arm. Depress the valve bridge, slightly moving in the plunger adjuster setting of the ball check with the trapping oil. Since the oil is practically incompressible, further movement of the rocker arm, excessive lash adjuster plunger face open exhaust valve. Alright, this shows your valve bridge assembly. Show the valve bridge, your bridge, seat and body, ball check, ball retainer, springs, plunger, lock ring, hydraulic lash adjuster. So here's your valve bridge, your ball check valve, plunger, lash adjuster, oil flow, and plunger. Prior cleaning the assembly of the valve bridge, clean assembly with a solvent. I use caustic type cleaner. The spring seat will damage. Or disassembly. Remove the lash adjuster assembly from the bridge using an adjuster puller, figure 224. We'll remove the hydraulic lash adjuster. Mount the valve bridge on some spring compressor and a vise 225. Install the valve bridge compressor, compressing spring. Remove the lock ring. Remove the spring seat and spring. Inspection. Visually inspect the valve bridge parts and replace those damaged beyond repair. Check for the pin end of the valve bridge seat so that it's tight, and all checks of the valve bridge are bent and shank. If the shank is slightly bent, it may be re-straightened and reused. Inspect the valve bridge spring seat at points shown in figure 226 and refer to the dimensions surface data at the end of the section. Alright, 1 would be your distance between rocker arm guide ears. 2, lash adjuster socket diameter. And then valve bridge shank. 3, 4 would be your shank diameter from the shank end to the above shank end. 5 is a spring seat with rim thickness. 6 is a spring cylindrical seat. Refer to the lash adjuster portion of the section from the maintenance qualification lash adjuster assembly. Alright, your lash adjuster. Depress the lash adjuster plunger, remove the locking ring, figure 223. Carefully disassemble the lash adjuster, avoid damaging the machine surface to the inside diameter of the body of the outside diameter of the plunger. Replace spring with a ball check, new parts prior to lash adjuster. Cleaning lash adjuster parts may be cleaned using fuel oil. Lacquer deposits can be removed with alcohol lacquer thinner or suitable solvent. Completely remove any dirt, lacquer, or metals particles. Do not buff inside diameter body, the outside diameter of the plunger, cylindrical radius of the tip of the plunger. Inspection. Inspect the body of the score if the scratches gulp with any of the machine outside diameter and replace if any are found. Inspect the plunger scores and scratches galling outside diameter, replace if evident. Inspect your plunge tip, and if contact point is worn more than 250 thousandths of an inch in diameter, the plunger should be replaced. Inspect the ball retainer, 166 thousandths of an inch diameter, counterbore depth of the center of the ball depression. Replace the ball retainer depth greater than 143 thousandths of an inch. Assembly. Assemble the lash adjuster in the area with 3 dirt lint metal particles. Qualifying lash adjuster recommended lash adjuster test stand, figure 227. Be used to qualify lash adjuster for use. Engine test stand automatically measure the time required for the lash adjuster plunger to travel from 660 thousandths of an inch while subject to 30 pounds of ram rotated at 10 RPMs. Relatively lash adjuster Body. Show the ram lock nut, rotating cap, electric timer, last adjuster test stand. A gauge block oil loading tool figure 227 is supplied with a stand on the gauge block is used for the check for the adjusting tripping of the point of the micro switch is necessary to ensure that the leak downtime is measured exactly at 60,000 of an inch travel. The last adjuster planning oil loading tool is used to change the last adjuster oil bleed off of any of the air that might cause the incorrect downtime intervals. The central electric motive hydraulic last adjuster's oil, but in conjunction with the test and soon to the operation test limits governing the last adjusting based on the use of oil. Our test stand operation. The ram starts with the tip of the ram at the 375,000 inch from the top of the rotating cup. The starting point should be checked at 375,000 inch gauge block supplied with the test should be checked often enough to pressure if not changed if the check is made by placing the gauge block on the top of the rotating cap at the tip of the facing lower of the ram, turning the ram, and leaf the time clock of the test stand should start with the very mount with the ram load contacts of the gauge block. If the time does not start with a start too soon, the ram should be readjusted. If this is done, loosening of the ram, the turning of the ram tip up down from the proper adjustment, right turning the lock nut time, the clock start stop micro should permanently set so the time at 60,000 of an inch travel is automatically recorded at the time block. If the micro switch has been replaced, the 60,000 inch between the micro switch position should be set at an inverting gauge block at 60,000 inch step on it. Alright, your test procedure. Place the last adjuster assembly in the oil loading tool and immerse with the container of the last adjuster of the test and deep enough of the hole of the last adjuster to be well below the oil level. To completely depress the last adjuster plunge at least 10 times and ensure that the air trapped inside of it is pumped out. Retract the spring loading plunger and oil the tool. Allow the ball check seat with the last adjuster prep the last adjuster plunger with 2 or more 3 times. Ensure that the bulk checking is easily set. The assembly should be filled with a firm without any giving into it. The last adjuster with the test oil with the remove of the loading tool. Be careful of the spring loading tool does not use. Unseat the ball of the check with excessive oil off the last adjuster. Place the rotating cup of the test and turn the switch to the rotate cup. Lower the ram until the rest of the last adjuster plunger. Release the handle of the plunger. Carry the full speed, full 30-pound load. Be sure the last adjuster is rotating around the plunger at a time of 60,000 inch travel that will automatically record the time on the clock. Leak downtime should be within the limits of the 10 seconds minimum, and 40 seconds maximum based on normal temperature at 75 degrees Fahrenheit. For oil last adjuster, if the temperature of the oil last adjuster is other than 75 degree, limits should be contained in the following. And it shows a table of minimum leak downtime, maximum downtime at different oil temperatures. The temperature of the test oil last adjuster should be allowed to become stable between leak down checks are made. Last adjusters fail to pass the minimum leak down test. It should be refilled and retested. Make sure the failure was not due to air trapped in the last adjuster. Alright, assembly of the valve bridge. Using the valve bridge spring compression figure 225, assemble the qualified spring seat and the lock ring to the valve bridge and install the last adjuster assembly of the valve of the bridge using an installer tool figure 228. Alright, your rocker arm. There are 3 rocker arms are mounted on the cylinder head. 2 rocker arms actuate 4 exhaust valves. The third operates the injector, and the rocker arms are operated directly with a camshaft, cam follower, roller mounted fork end. Each rocker arm. Opposite end, each rocker arm has adjusting screw locking, setting injector timing, adjusting hydraulic adjuster. Injector rocker arm, although similar appearance to the exhaust rocker arm, stronger with the exhaust rocker arm identified with a yoke. Can be identified by the yoke at the cam follower and the square shaped and which is square fitted shaped on the injector rocker arm but V shaped on the exhaust rocker. Also, injector rocker arm has a machine notch where overspeed trip. Injector exhaust rocker are not interchangeable. Lubricating oil supplied with a cam follower, assembling the adjusting screw through the drilled passage of the rocker arm. Remove the adjusting screw with the follower, raise the bushing and pin. Thoroughly clean all parts and fuel oil similar solvent and do not clean inner and outer races. And bushing caustic solution. Handle parts, care avoid nicking bearing surfaces. Inspect rocker arm Bushings followers runner inlet race. Figure 230 with a rocker arm shaft with evidence of the heat discolor is a successful wear, shelling scuffing due to lack of lubrication fatigue cracks. Figure 230 shows the injector rocker arm exploded view. So we'll just go a little bit more in. Shows the cam follower ruler, floating bushing lock nut, inner race, cam follower pin, taper pin. It shows your lock nut, adjuster screw, and here, and air button spring, injector button, rocker arm. All right, check check that all holes and passes are clean. All adjusting screws should be checked with a hand-free operation. Gouging on the ball and adjusting screws button should be visually checked for galling and cracking. So this one's the injector screw. This is about the only difference, really. Alright, rocker arm support assembly. Okay, there are 3 rocker arms mounted on the rocker arm which held the end of the position shaft support. Lubricating oil supply with the rocker arm, drilled passages, rocker arm shaft, oil supply line from the camshaft bearing bracket. 2223 1 shows rocker arm support shaft, rocker arm, and then this shows the shaft support cap, shaft support. Alright, maintenance. Thoroughly clean shaft support, caps support the solvent. Check oil passages and shaft oil line clean, free of the obstruction. Check shaft diameter of the wear proper dimensions. Check for the scratches and galling and bearing areas. Check shaft support correct height of the dimensions between base and bottom bore. Hold dimension with limits with ensure the height mismatches between supports at any one of the cylinder at 6,000 inch mismatch greater than can lead to the camshaft lobe distress, broken rocker arm studs. A flat true nut seating surface must be provided on the support cap. Broken washers and studs can result. After seating surface damage, it may be remachined until minimum dimensions of 1.5 inches obtained with the seating surface at the top of the bore. The surface machine squared of the set hole of the pail with the center line of the central line of the rocker arm shaft at 10,000 of an inch. Total indicator reading. Cracks, cap shoes, shaft supports are caused with rejection. Your cylinder test valve. All right. The cylinder test valve provide each engine cylinder anytime maintenance and the inspection is performed. The valves are open, relieve the compression, reduce the effort, rotate the crankshaft. The test valves open, fuel open, coolant leaks can be detected. Fluid discharge of the valves. Valve opening is being barred over. Cylinder test valve is installed, inserted hosing the crankcase, screwed with the cylinder head, the cylinder test valve wrench. In Figure 223, the 233 is open and closed valve. Figure 232 shows the test valve, cylinder test valve, cylinder head, crankcase, compression relevant, packing nut, test valve, seal. Show the test valve wrench. Maintenance. If the cylinder test valve is leaking, check with the packing nut that has been torqued to 60 to 65 foot-pounds. If not, over-tighten chain seal. Figure 232, check correctly tighten the package nut. Should be valve with a continual leak. Remove the valve from the engine ream. This valve seat. Figure 234. 234 shows the reaming valves testing the valve seat. If reaming will not correct the leaking due to the scored or damaged valve stem face, it should be reconditioned. Limited figure in 235. Reharden tip of the depth of 5,000 to 10,000 of an inch. The cylinder test valve with the rework with the dimensions shown figure 235 of the reamer reconditioned valve stem necessary to exceed 1/4 of an inch maximum diameter valve seat. Figure 235 recut with 1/2 inch diameter counter bore. Reface hex and end of the 6 and 1/6 of an inch normal dimension. Figure 235 shows test valve reconditions. Now, needle valve tip test valve body. After recondition, air test valve assembly at 90 psi air pressure. Alright, your cylinder head test seat ring. Description: cylinder head seat ring and a brass ring between the cylinder head seat with the cylinder head to improve the seating surface of the cylinder head to maintain proper position with the crankcase. Maintenance inspection hard seating ring proper dimension ring does not meet the required specification should be replaced with a new ring. And then it goes over surface data: cylinder head vertical angle 30 by 0 foot, 30 degree, 15 foot. Valve seat width 93,125 thousandths of an inch. Variation seat width are given it a max 15,000 inch. Diameter of the top of the valve maximum 2.437 inch, minimum 2.375 inch. Valve seat run out max 4,000 inch. Valve flat to the head 15,000 inch. Maximum 93,000 inch. Valve lift 688 thousandths of an inch. Fireface circle refinishing circumferential lay 80 to 120 U inches. Exhaust valve stem diameter new 6,200 6,215 thousandth of an inch, 6,225 thousandths of an inch. Diameter head angle at 2.5 inches. Vertical face angle 30 0 foot 29.45. Valve seat run out max 2,000 inch. Valve rim thickness minimum 109 thousandths of an inch. Valve face width 343 thousandths of an inch. Valve spring 125 thousandths of an inch. 3.968, and then it continues and it goes over all the rest. Alright, this is section 2 of the electric motor division, cylinder head and accessories.